All right. So again, we're talking about parallelograms today. So side AB is congruent to which side?
CD.
Okay, good. Because remember, in a parallelogram, opposite sides are congruent. So side AD is congruent to what?
BC or CD.
To BC. Okay. And then angle D, this angle right here is congruent to what?
Angle B.
To angle B, because remember the opposite angles are congruent to each other. Okay, so what is the sum of the interior angles of this? So if you were to add up all four angles, what would they add up to?
360.
Okay, remember, if you forget the formula, no, you were right with one of those numbers, but I just want you to remember this. If you forget, use the formula n minus 2 times 180. So this one has four sides, so 4 minus 2 times 180 is what?
360.
Is 360 degrees. Okay, I'm going to go ahead and move on. So today we really are pretty much talking about the same thing that we have been talking about. It's just we're working in the reverse. So what we've been doing is we've been saying, okay, if it's a parallelogram, this stuff is true of it. Well, what we're doing today is we're saying, okay, if these different characteristics are true of it, then we know it's a parallelogram. So we're going to talk about these four different conditions that we're going to use to prove that a quadrilateral is a parallelogram. So the first one here is that if both pair of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So here's what we're going to do. We're going to number this, and then that way later, as we go through the lesson, we can just refer back to the number instead of having to write the thing out each time, okay? So for the first one is that both pair of opposite sides are congruent. So if both pair of opposite sides are congruent in a quadrilateral, then you know that that quadrilateral is a parallelogram. And that by itself is enough information to know that it's a parallelogram. If you know both pair of opposite sides are congruent, that's good enough to say that it's a parallelogram. Okay, the second condition is that if both pair of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So this will be our number two condition, is that both pair of opposite angles are congruent. Then we know that that quadrilateral is a parallelogram. So if both pair of opposite angles are congruent, it's a parallelogram. That's our second condition. All right, the third one is this, is that the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if the diagonals bisect each other, then we know that it is a parallelogram. So those are the first three conditions, and basically those three we've talked about in the last two days that we've been talking about parallelograms and their properties. This fourth one is not one that we've necessarily talked about. I mean, it's nothing too different from what we've been doing, but we haven't really looked at this particular one. So the fourth one is this, is if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. Okay, so this is our fourth condition, is if one pair is both, let me say that a little different, I'm sorry. If one pair of opposite sides is what I wanted to say. If one pair of opposite sides is both parallel and congruent, then we know that it is a parallelogram. So what we're going to do as we go through here today is we're going to refer back to these four conditions as we decide whether a quadrilateral is a parallelogram or not. So on this first one, we're going to do two things here. We're going to say if it's a parallelogram, yes or no, and we're going to give the condition that justifies that being one. So on this first one right here, You think this quadrilateral is a parallelogram? Yes, and I agree with that. It is. Based off of which condition?
Number 1.
Okay, so somebody has voted for 1, somebody has voted for 2.
Oh, wait, angle. No, it's not.
So with the information they've given to us, 35 and 35, 20 and 20, which one of these conditions does that information fit into?
Should it be 1 and 2?
Okay, so I have 1, 2, and somebody said 1 and 2. I need a deciding vote cast here. Have you changed your vote?
1, 2, 3, and 4.
Nope. It's not that hard. It clearly fits into one of these. Very, very obviously clearly fits into one. No, it's because your minds are not fully engaged. If you were thinking about it, this side is 35, this side is 35, this side is 20, this side is 20. It's talking about how long the sides are.
So then 1, right? 1. It's both. There's about 2, 3, 4.
Okay.
It's 1 because look at the thingy. It has the 2 lines and 2 lines. No, the top.
Okay. So congratulations, you were right in the first place. It is 1. It is 1. Look, this side is congruent to this side is congruent to this side. Both pair of opposite sides are congruent. This is like very, very obviously condition number 1 right here. Okay. This second one, is this one a parallelogram?
Yeah.
Yep, I agree.
Because of the 4th one.
Yeah.
Good. That is because of the 4th condition. Remember, whenever you see this extra set of arrowheads, they're indicating that those two sides are parallel. So notice how this opposite pair of sides is parallel and they're congruent because they're both 15. So this one is yes, based off of condition 4. Okay. Is this one a parallelogram?
Yes.
Yes, based off of which condition?
The second.
Off the second condition because the opposite angles, both pair of opposite angles are congruent. Okay, number 2, is that a parallelogram?
No.
Right.
Yes.
Yeah.
Off the first condition?
Yes, off the first condition. This side is congruent to this side is congruent to this side. Okay, is number 3 a parallelogram?
No.
No.
No, definitely not. You can see how these two sides are different, these two sides. Okay, good. And number 4 is yes, based off of condition 3. The diagonals bisect each other.
I can do this. I can do this there.
What?
Okay, on the back. So, really the math is no different than what we've been doing. It's just looking at it a little bit different. But the top here says, find x and y so that the quadrilateral is a parallelogram. So for this, and I wish this rectangle wasn't around because that's confused people. Just ignore this rectangle. That was just to box it in because it was kind of a mess when I first was doing this. Got plenty of white space now, but that's all the rectangle was for that. We're talking about this blue one in here. So I want to know the value of the x and y that makes this a parallelogram. So in a parallelogram, what do I know about side AB and side DC? They have to be congruent. So what I want to know is what value of x makes these two sides congruent to each other. So how can I find out what value of x makes these two sides congruent?
The first X, the second X.
Yeah, we're going to put this equal to this and see what the x value is, right? So here's what I'm going to do. Is I'm going to go 4x minus 1 equal to the 3 times x plus 2. See, what I'm doing is I'm setting them equal to find out what value of x, makes that situation true. So from here, it's just simple algebra. So to solve for x, what do you think my first step is going to be here? Distribute. Yes, good. So the 3 gets distributed here, the 3 gets distributed here. So what's that going to be on the right-hand side? 3x plus 6, and on this side we still have the 4x minus 1. Okay, good. Let's get our x's together. So I'm going to subtract 3x on both sides. This gives us x minus 1 equals 6. Add 1. And x equals 7. Okay. Now what I want to do is I want to take that 7 and plug it back in up here and see if that does make those two sides equal. So if I plug in the 7 right here, what's 4 times 7?
28.
And 28 minus 1 is 27. Okay, if I plug in this 7 here, what's 7 plus 2? 9, and what's 3 times 9?
27.
Is 27. So that makes this side congruent to this side. Okay. Now let's do the same thing on the other one. Okay. So the y's, this side AD needs to be congruent to side BC. So we're going to go 3 times y plus 1 equals 4y minus 2. So I'm going to distribute the 3 here. So we get 3y plus 3 equals 4y minus 2. Subtract 3y from both sides. 3 equals y minus 2. Add 2. Y equals 5. So let's plug that back in to make sure that that does balance this out. So if I take 5 and plug in here, what's 5 plus 1?
6.
And 3 times 6 is 18. And then if I plug in that 5 here, what's 4 times 5?
20.
And 20 minus 2 is 18. So that does make this side congruent to this side. Okay, so which condition does that fit into then?
Number 1.
Fits into the first condition, right? Because we see now that this side is congruent to this side and that this side is congruent to this side. That's the first condition. Okay, next one is the same idea. Find the value of x and y so that this is a parallelogram. So remember, in a parallelogram, what do we know about what's going on inside of here? What's the property that we talked about?
It's the third
Yeah, what does it say?
supplement. Diagonals bisect each
The
other.
diagonals bisect each other, right? That means they split each other exactly in half. So that means that this piece needs to be congruent to this piece if it's bisected, if it's cut exactly in half. So what I'm going to do is I'm going to set them equal. I'm going to go 8x plus 12 equals that 3x plus 37. And then just solve for x. So we're going to go minus 3x on both sides. 5x plus 12 equals 37. Minus 12. 5x equals 25. Divide both sides by 5. And x equals 5. Now, let's plug that 5 back in and make sure that what we said is true. So if I take this 5 here and plug it in here, what's 8 times 5?
40.
And what's 40 plus 12?
52.
Is 52. So this would be 52 feet. And if I take the 5 and plug in here, what's 3 times 5?
15.
And 15 plus 37 is 52. So yes, we can see with that value of x, that makes those two equal to each other. Makes those two pieces congruent. So that shows that that diagonal is bisected. Now let's think about going the other direction like this. This piece and this piece should be congruent. So 6y plus 7 should be equal to the 3y plus 40. Subtract 3y from both sides. We get 3y plus 7 equals 40. Minus 7, 3y equals 33. Yep. So y equals 11. And I'm going to plug that 11 in here. What's 6 times 11?
66.
And 66 plus 7?
71.
I think it's going to be 73, right? And if I take that 11 and plug in here, what's 3 times 11?
21.
33.
33. And then 33 plus 40 would be 73. So here you can see this is 73, this is 73, so that makes this piece congruent to this piece. And again, that's what bisected means. Okay, so this information right here fits into which condition on the front? fits into the third condition, exactly. The diagonals have bisected each other, so it is a parallelogram. Okay, so we looked at 4 ways to prove that something is a parallelogram, but there's other ways to do that. And another way to do that is by just using the definition of what a parallelogram is. I mean, just based off of, the actual word. A parallelogram having parallel sides. So that's what we're going to do is we're going to show that both pair of opposite sides are parallel. So the question is this thing a parallelogram? Does it look like it?
Yes.
It looks like it, but that's not good enough to say that it is. We need to prove it. So the way we're going to do it is we're going to prove it by showing that this side is parallel to this side. What does it mean for lines to be parallel? They never intersect. Now, how can we know if 2 lines are parallel? We've talked about this earlier this year. It's been a while ago, but we have talked about it. Yes, that's true. But how do I know that they're not going to intersect, 1,000 units from what we can see on here, or 1,000,000 units? How can... Okay, you're getting closer. Okay, what is that you're getting at? I know what you're getting at. What do we call that? Okay, good. Rise over run, you're right there now. What do we call that?
The slope.
The slope. Good. So remember, if 2 lines have the same slope, they're parallel. Okay? And let me remind you, the slope is rise over run. Rise over run. So what I want to do is I want to find the slope of this line segment right here, TQ. Okay, so that's what we're going to start off with, TQ. So rise over run. The top number is the up down. The bottom number is the run. It's the to the right movement. So from T to Q, first of all, how far up do we go? Go up 4 units. So 4 is the rise. What's the run? How far do we go? 1. So the slope of TQ is 4 over 1. Now let's look at the other side, this SR. Okay, the side that should be parallel to it. What's the slope of SR?
4.
Up 4 over 1. So, yep. So are those 2 sides parallel to each other?
Yes.
Yes, these 2 have the same slope. So that means that this side is parallel to this side. So I can put my extra set of arrowheads on there. Now we're going to do the same thing for the other side, other pair of sides. So QR. Okay. So from Q to R, first of all, how far down do we go to get from Q to R? Go down 2, and then how far over? 4. Down 2 over 4. And we could simplify that here, but we don't really need it for what we're doing here. Now for TS, what's the slope of TS? Down 2 over 4. Are those 2 going to be parallel? Yes, because they have the same slope. So this side is parallel to this side. And just based off of the definition, since this side is parallel to this side and this side is parallel to this side, that means that yes, this is a parallelogram. Yes, that is a parallelogram. Based off of the definition of it, both pair of opposite sides are parallel. Okay, and this last one, I want you to plot those 4 points and connect it and make that quadrilateral. So plot those 4 points and connect them real quick. Okay, so that's what it looks like with those points plotted. Does this look like a parallelogram?
Sure.
Yeah, no.
It does not look like a parallelogram to me, so it should be pretty easy to prove this. These two sides look like they're maybe kind of close, but I mean, it's pretty obvious to me when I look at this. This one and this one are not parallel. So we're going to test that though. We're going to count the slope real quick. So let's start with EF, okay? Let's find the slope of line segment EF. So to get from EF, how far down do we go?
1, 2.
And then how far do we run?
4.
So we go down 2 over 4. Now let's check the side that should be parallel to it, which is HG. So what's the slope of HG?
Down 3.
Down 3 over 4. Do those have the same slope? Okay, so these are not the same slope. That means this is not a parallelogram. It's quadrilateral, but it's not a parallelogram because, you know, those two sides are not parallel to each other.